Good. Okay, let's get started. Here we go. So regarding the quiz, this little assessment we had last time, I want to talk about number 2. I went back through and I changed some of the grades. Some went up, some went down, but I want to revisit this because I think it's important. But so if you have, when I load those up on Blackboard, you'll see that you may have a different score because of number 2 than what you came up with. And so the first thing was, if you use this as your arbitrary point, I gave you the points back. Okay, if you use that as the arbitrary point, because I didn't really label those 2 points with the ordered pairs. So if you did that, I gave you those points back. And so there were some other situations where you deserved more points than you gave yourself. But then there were people that gave themselves too many points, and so that's mostly what I want to address. So a week ago, I walked through this process of building the equation of a line. And that process was specifically about utilizing constant rate of change to do that, utilizing the principles of constant rate of change. And what are our principles of constant rate of change? We've talked about how the change, such as say dp, is p final minus p initial, right? Okay. We've also said that P final was P final equal to? P initial plus the change in P. And we talked about how those should make perfect sense totally in isolation from one another, not just one algebraic step away from each other. They are. But it should make sense that the change would be the final minus the initial value of a quantity, and that the final value of a quantity you would get by starting with the initial and adding the change. And then finally, if P and Q are in constant rate of change, then what relationship do we have? So I'll just say dq is equal to? And then is Q equal to M times P? Maybe. If Q is 0 and P is 0, then yes, also Q equals MP. But if Q isn't 0 when P is 0, then that's Q is not equal to MP, but this is always true for constant rate of change. So so we want to build the relationship, in this case, like of Q and P, all correspondence points, using these principles, and and so I went through that last Thursday, and I said, how many have not done this before? Do you remember that? I said, has anyone not done this before? Okay, and no one raised their hand. I said, really? Okay. So because my experience is that I show students this, and we talk through it, and they say they get it, but they can't reproduce it. So I want to point out that this process that I'm showing you is different than this. I find that, what was the constant rate of change for this? Does anyone remember? Negative 1, how about one person? Negative 13 over 40? Okay, so here's what the process I showed you is not the same as. And I just don't want you to be, I want this to be clear. That you find the constant rate as negative 13 or 40, and then we have the initial point, 35, 41. And so I know that y minus y1 equals m times x minus x1, and I can put my rate of change there, and I put my point there, and then I can add, if I need to, I can add that point over to the other side, and so I get y equals negative 13 over 40 times x minus 35 plus 41. Okay, so that is the same end result as the process that I was showing you, but Did you notice I talked out loud? Did you notice my process of thinking there? What did it have to do with constant rate of change? What did it have to do with? Just knowing a formula and putting things in the right place. So let me talk through this. So the kind of using this process. So we start with at 31. I'm sorry?
Are you going to record today?
I am recording.
Oh.
Already. Yes. Okay. All right. And so yeah, it's because for some applications you see the little red, but for others you don't. Okay. Yeah, it is recording. But yes, thanks for reminding me. Okay, so and we know this is that second point, so I'm going to pick an arbitrary point, and what is that? That represents every point, x, y. So that represents every correspondence point of, in this case, minutes since class started and battery charge. And what comes first? What comes first? A change in time or a change in percent? Change in time comes first. Lots of you guys had this in your drawing. This. And that would indicate what? Yeah, so the change in percent results from the change in time, so we want that change in time to be first. And so that we call that d, I just got to be consistent, so just use x and y. So dx, and what is that change in time? So starting from 35 minutes to any time x, that change in time is x minus 35. And then as a result, we know that we're assuming that the battery percent decreases at a constant rate. So therefore, we know the resulting change in battery percent, which is? Right, so constant rate of change says that changes in one quantity are the constant multiple of the change in the other. So we got negative 13 over 40 times dx. And then as a result of y changing that much, we can then write what our final y is going to be equal to. Our starting y plus, oh, and I didn't, plus the change in y, right? So now I'm going to apply this principle here, where that final y is the starting y plus the change in y. And that change in y is the negative 1340 times x minus 35. So I spoke out loud, doing it both ways. Different or the same? Monumentally different, right? Monumentally different in how I arrived at the exact same thing. So if you just wrote down something like this, it's indicative that you didn't think through the process. You could have wrote all this down and not really thought about constant rate of change, but at least there's a chance. At least there's a chance you thought of it. I can't read your mind perfectly, but there's a chance here if you follow these, change in x, resulting change in y using constant rate of change, and then y final equals I initial plus the change. At least there's a chance that you're thinking about where this point comes from, where this resulting xy point comes from, rather than just, I know this formula, I'm going to put things in the right place. Okay, so I just wanted to kind of just give you a little explanation or why your score may be a little different. If I saw something more like this, I really didn't see you applying this process of thinking through how constant rate of change can give us this line. All possible points of time after class started and percent battery change. Any comments or questions on that? Okay, so we want to practice it one more time? Let's do that. If I can find it here. This is it. So there's probably more here than we need to do, but so we don't need to do number 2. You know what? Let's just do it all. It's good. But what I'm really getting at is 3B. 3B is this thing that I really want you guys to embrace. Okay, this thing of using constant rate of change to build the equation of a line, rather than inserting numbers in the right places. Okay. So if you want to work together, that's good. Maybe let's just instead of working at whole tables, maybe just with one other person. Like so, just the person. If you can pair up, you can work by yourself. That's great. But if you're going to discuss it, then let's just do it with maybe one other person. But what our real goal here is 3B. 3B is the real goal that we're going to practice this process of thinking it through.
Is this something?
No, just practice for your notes. Just for your notes. But take it just as seriously.
Yeah, I only asked to.
Yeah, that's great. Sure. This is true, though. Did you guys know this? That there is a relationship of how many chirps per minute and temperature. This is a real thing in life. Okay, I didn't make it up. Yeah, let's just skip 2. Don't worry about 2. No, definitely do 1. So we're all on the same page. We got the same. All of us have the same symbols. Okay, so definitely do 1, and then we can skip 3A as well. Just go right to 3B. And if you want to use GC to get your given points, get a picture of your given points, that would be great.
If crickets just chirp about it, it's not going to get hard. I know that. So I think.
Okay, so our goal is that everybody understands this fully. So please ask if you are unclear about something.
100? Yeah, which is the change.
100 degrees?
100 chirps.
100 chirps. Okay.
And then 98 degrees.
Okay.
And then 96 chirps.
Yeah.
And 81 degrees. It almost makes it yeah.
Okay. Okay, so is there someone who, like, in this class period just now has made great progress in this? Morgan, so can you get me started here? So what point do I... This is the point, what?
That one, I made 198 my point.
Do you want to use this one? Okay, and so what do we need? So we're trying to do what? What's our goal?
Our goal is to our goal is to be able to use any arbitrary point and find the relation, define the relationship for any 2 points.
Right. Simultaneous values of these quantities. Right. So so how do we do that? We start by just picking a point, and I could have picked that here or even down here. And what do we call that?
XY. And then first you're going to do the dx. We'll draw the and then dy.
Let's say what dx is.
Oh, so dx is equal to, well, several things, but, well, I said x minus 100, but it could also be just like the initial, the initial point, the final point plus the final point minus the original.
No, but we're defining dx. We're defining dx. We're not defining x final.
Right.
So it's like you're trying to now also represent x final. We're just defining dx.
So is that right?
Yeah.
Could it be 100 minus x?
Could be.
As
Yeah,
long as your dy is also like 98 minus y.
Yeah. So if you picked at that xy point down here,
Okay.
where x was less than 100, then
That's okay.
well,
I picked mine.
no. I mean, yeah, but then then it's like you're going from.
They'd both be negative, and then when you do the dy over dx, it'll be positive. It's preferable.
Yeah, it'll all work out with the signs, but.
It's preferable to pick.
Yeah, it's just kind of convoluting it. Yeah, so just make your final point be the arbitrary point based on our initial reference point.
Bigger
So
x
x minus 100.
What's that? No, but
X minus 100 is weird, or does that work?
no, you're great. You're great. But even if x was down here, it'd still be x minus 100 if this is our starting point. If this is our reference point and x is less, it's still final value minus initial, so it'll still be x minus 100. It's just that would be a negative change, dx. But it'd still be x minus 100. Okay, so that's the first thing we think about is the change in the independent variable from our reference point to our arbitrary point, which should be x minus 100. Okay.
And then we have dy, which is,
As a result of that change in x, we have a change in y. And how much is that?
y minus 98. Because it's, again, our
Okay,
final value minus 98.
but since we're trying to find that, we don't want to use that.
Oh, right.
So we want to use constant rate of change instead. Let's use that dx that we have.
So then dy equals n dx.
And what did you guys calculate for m? 17 fourths. And dx is? Okay, so what I realized, this was great for me because many of you from here went to this. You did this point slope form. Okay, but we don't need it. We don't need it, and it's this third step in the process that's causing the sticking point, right? And so it's like we're defaulting to this point slope form that we've memorized and making it kind of work when we can just go right to defining what y is if we just make sense in this third step. So what is y final equal to? If I'm 70 inches tall and my height changes by 2, how tall am I? 70 plus 2. You just add them, right? So you should just take the initial value of y and just add the change, and you get the final value. But there's a block with this. So lots of us struggled with that. That's okay. So I'm glad I learned that. But if you want the final value of a quantity and you have the change, what do? Add it to, Ben?
Add it to what you had when you started.
Add it to what you had when you started. So what you have when you started plus how much you change is what you have in the end. So we can just apply that and we're done, right? So what do we have to start with? 98 degrees, right? We started at 98 degrees. And how much did it change from there? dy, which we just found. Not needed. Not needed. You see? It makes perfect sense that if you have the change, you take the starting value, you add the change, and you get the final value. Not that you can't make meaning out of this. I'm not saying you can make, you can definitely make meaning out of this. Change in y equals m dx, for sure. But if you found the change in y, and you knew the initial y, then you just add them. You just take that initial y, add the change, gives you what you're looking for, which is our arbitrary y final. And then that represents all the points on the line. Okay, comments, questions? Please, Ron.
Or if we use the other given point as our initial,
Uh-huh.
it'll be okay.
Okay, so what would happen if we start, what was the other point? 81?
Yeah.
If we use that point, what would happen? Our change in x would be?
X minus and then your initial would be 81.
Right, so then it would be, you'd have, if we work through it, we'd have y equals our initial point plus the change in temperature, which is still 17/4 times the change in.
X minus 26.
Okay, so
So either of those would be okay.
why are either of those okay? Are they the same, Jacob?
Yeah, just have a different initial.
Are they the same?
Yeah.
Okay,
They're both-
let's some of you get the mx plus b form of the first one. Some of you get the mx plus b of the second one. Okay, go. So some of you can use GC if you want, but figure out what mx plus b is using the first thing we did up top, and then some of you calculate out what mx plus b would be using the second one. What'd you get? (17/4 x)
For the second one, I got negative 327.
minus 327. Exactly.
Yes.
First one also. Both cases.
Yeah, minus 27 is the other.
Okay. What's a big advantage to this way of developing a line versus mx plus b? Here's a great example of why mx plus b is deficient. Or
We don't always care what the y-intercept is.
okay, do we care what the line intercept is here?
Negative 327 isn't meaningful to me, like, right off the bat. Like, the rate of changes and,
Okay.
and the data that we have at point.
All right. So the rate of change is meaningful. Is the minus 327 meaningful in this context?
It doesn't seem like
It would say that what? If he's not chirping, it's what? We're all dead. Right? All mankind is dead.
Also, y equals mx plus b kind of makes you rely on a graph and looking for the y-intercept. I feel like we were trained to be like, okay, now look for where your graph intersects,
Okay.
and that's your b. So if you don't have a graph, then it's not. Although you and students don't construct as much meaning out of it.
Right. So it's kind of like start with the graph first to figure out
Right.
b, but here we're actually making the relationship ourselves. Other comments about that? What about in your piecewise generator? So say we use the piecewise generator and we get something like this. Okay, so look at here's interval 3. What about the y-intercept of that? So say this is a function. So we're building a real world function that has meaning, but it's a piecewise linear function. So we're going to use our piecewise generator. What about the y-intercept?
Do we care?
Does it have relevant meaning to this function?
No.
It doesn't, right? It doesn't really have meaning. But what did you do? You used this thing. You had what? So if this was, say, x2, y2, what did you do? You should have done was y2 plus rate 3, I guess this would be rate 3 times x minus x2. Does that form have relevance for our function? Everything in that has relevance for our function, right? You've got the initial point, x2, y2, where the new rate starts. You have the rate. What does the x minus x2 represent? Yes, it's dx, but like talk about it in terms of this function. Like what is x minus x2 in this?
Gets you to the next piecewise victory. Oh, no, I'm sorry.
What does x minus x2 represent relative to interval 3? What's that? Is it the width of interval 3? Is that the width of interval 3? It's not the width of interval 3. Fern, so what is it?
So it changes with wherever x is.
Right?
Right.
So how can you talk about what this value of dx means? What's that? The change from some arbitrary point to x2. What do you guys think about that? Other way around. Okay, so the change from our starting point to any point in that interval, right? So it's like how far we've progressed through this interval. It's how far in x we progressed through this interval for whatever the current value of x is. Okay? So then what about this? Does this have meaning? R3 times x minus x2. Changing it to be more specific then.
The change in y from the, well, it's just the change in y from the x2 to y2.
Okay. It's the corresponding, so for how far we've gone into this interval now, it's the corresponding change from y2, right? The corresponding change from y2. Add y2, and you get the y coordinates, right? So this form has a lot of great advantages over mx plus b. Okay. If you tried to build this piecewise generator out of mx plus b, it'd be awful, right? It'd be awful. So that's why this thing is really helpful. Same with the what about y-intercepts of your secant line, your average rate of change animator. Again, this is tremendously advantageous to use this form of it. Okay, you should have found that. You should have found that you're not doing y equals mx plus b to graph those secant lines, right? Okay, very good. So let's change gears a little bit here. So here I've defined 2 points as A and B. So A is 3, -1, B is 7, 5. And then if I just type in then A and B, then it'll graph those. Okay? So my question is, don't put this in GC. You have to grapple and investigate without just doing it. So don't know, hands off your keyboards. This next line. 1 minus t a plus t times b. T is what's called a parameter. It's a parameter, and it takes on a range of values. Okay, it takes on a range of values, and GC will perform it for all the values. So perform whatever mathematical statement you have, but for all the values. And right now t is set. You can look. It's very small over here to the right. T is showing starting at 0 and ending at 1. Okay, so t is going to start at 0 and end at 1, and this will what will this do? So if t is assigned to all those values between 0 and 1, what will this statement result? What will GC? So are you going to think about it? So you answer my question, or do you have a question?
I think I'm answering the question.
Okay, so I want everyone to kind of think about it before. So I'm putting the question out there, but I'm not asking for individual response now. So I want you to, without using GC, what will that, when I turn that on, what will that do? And then you may have a guess, but why? Okay, so not only what will it do, but justify your answer. Okay, go.
Lower T is like if you're looking at the T is lower T will range from 1
So the
Okay, there's lots to grapple with here.
So we're scaling from 0 to 1. And then we're also scaling from 0 to 1. So 1 minus t is essentially the same as t.
No. So 1 minus t.
If you add one, would this be like a
So I think B would start.
if you didn't have any teams and you added a plus B,
I don't
you
think it's
get
a
10.
whole. I think you're right.
For example, because you add the value. That's what I was talking about. Like,
Yeah, when
if
you're right.
teams like you would like make then right? 1 minus 0.2 plus.
So yeah, it's just like
You got it. No, well, then that's why I was like, oh, thank you. I'm sorry. Well,
yeah, what is it?
and then so maybe that's like,
Together
but then you would be out.
yeah, I think
Oh, sorry.
We used to have one straight line.
We had type
one fee would be 75. So think of what happens like between. So T is
So you get this, so the first part is this line, so it gives you, I think it was maybe points from the little blue ones. That's what I was thinking, but I couldn't find the words to say. A goes from
Sorry.
0 to 1. You can or 0 to B. But then
1, you get B, and I asked you to find, well, for t is 0.5, what do you get?
5 to
5, she got the 0.52. Did you get the 0.52 when t was 0.5? And is that the midpoint of those? Okay, so now it's showing what? It just showed the set of points for every t value. For every t value from 0 to 1, it just showed those points. Okay. So another example of this. Now I've got something else, something new. Here's 4 cosine x. The function f is 1/4 x squared plus 5. Okay? And so right now n equals 0. If I turn this on, what will GC do with this line right now when n equals 0? When I turn this on, what's that?
Well, n equals 0. Oh, add.
I'm going to turn this line on. This line right here, the second to last line, and right now n is set equal to 0. What is GC going to do? What's that? He said it'll graph g of x.
Yeah.
Vern agrees.
Yeah.
So red plus blue equals indigo, not purple, indigo. All right. So yes. So when n equals 0, if I turn that thing on, and so now I'm going to change n from 0 to 1. Figure it out. What's going to happen? I'm going to change n from 0 to 1. I'm going to change the value of n from 0 to 1 gradually.
So it's just going to be that.
Are you just moving N, or are you going to place?
I'm gonna do it slow. Make sure it goes slow. So I'm just gonna change n from 0 to 1. Doesn't matter if I play it or if I do it by hand. But just speed and. What's gonna happen? What's that? When x is 1, then what do we have? So if n is 1, what do I get if n is 1? So that was, I had that turned on from before, right? So this line that we're questioning, investigating, is showing when n equals 1. What is it showing? It's showing f of x, right? And we know when n equals 0, it shows that. So if I change n from 0 to 1, what will we see? Can someone try to describe it? What's that? What'd you say? Like this? Are you ready?
That is what I wanted to happen.
Here's n equals 0.3. N equals 0.3. So what is it? 0.7 times the function g plus 0.3 times the output of f. Right? So for any given x value, you're taking what? 70% of the g function and adding it to 30%, or the value of g, adding it to 30% of the value of f. Okay, but more than just looking really cool, more than that, this construct, so
Does t default to 0 to 1?
what's that?
Does your t value default to a range of 0 to 1?
I set n from 0 to 1. Oh, right, so, yeah.
Okay.
So what did we see? That the capital X and the capital Y, it can be an ordered pair. Sorry. It can be an ordered pair. It could be, those could be functions. Those certainly could just be values, all right? So this kind of mathematical construct is really, really useful. And so you have to be on the lookout for uses of it. What does it do? It gives you, when your t is 0, it gives you fully x. Whatever x is, it could be a point, it could be a value, it could be a whole function. It could be other things too. It could be a whole set of things, right? It could be a set, all right? When t is 1, you get y, right? So you get whatever y is. It's the point, the value, the function, the set of things, whatever it is. Okay? But then as t is allowed to change from 0 to 1, you get, how can you describe? What do you get as t is changed from 0 to 1? Or if you want to just spray all the t values between 0 and 1. What is it when t is not 0 or 1?
Well, in terms
But
of functions.
But x and y could be anything, right? X and y could be a value, they could be values, they could be ordered pairs, they could be sets, they could be functions.
Relationship between nature and nurture.
What's that?
Like a relationship between like nature and nurture, where like one goes up, the other goes
Okay.
down.
All right?
The transition between the two.
Exactly, right? So you get this gradual transition from one to the other. Okay? So you have to, we're not, just all, you got to have this at the ready, because this is a really, in terms of making animations, this is a really powerful construct that is really helpful, and make sure the command lines that you choose can bring great efficiency to the command lines that you choose to create something. Okay? Yeah, question?
So for the first one we did the 2 points,
Uh-huh.
did you just graph, like how you mentioned putting all of the t values at once?
Right.
Was that the way you did that one, or did you do
So that one was based on t, and GCT is a parameter, and so it just sprays all the values from 0 to 1 simultaneously. This one, I used n, which we control, and n only takes on one value at a time. And so I'm controlling that value. That's why you saw the transition.
Mm-hmm.
So a little easy project for you. So instead of having, so how could I show a point moving from A to B? How could I show a point moving from A to B? Just use n, right? If I just used n, then as I changed n, then it will just, that's a little distracting. Okay, then if I change n, then just one at a time. It'll show those points one at a time, whereas t sprays all the values simultaneously and shows the segment, right? Okay, we got to go. So I've done my best to explain that the thing due Tuesday as well as I can. Please email me if you have questions about that. But watch the video several times, read those instructions carefully over and over again, and resolve. So listen up. As you're planning to do this next project for Tuesday, please listen. Please stop talking just for a moment. You can pack your bags, that's fine. But watch the video, read. Watch the video, read the instructions. Make sure that that is congruent to you. Make sure what you're reading is congruent to with what you're seeing before you start. Okay? So